Good morning, Miguel. All right, so with number 4, a lot of people got it wrong the first time they tried it. What do you have to be careful with?
Aligning order, right.
Charlize, what'd you say?
The ones that, so you know how it's in the order?
Uh-huh.
That's when you see that like PQ is congruent to UT.
Good, so not congruent to, but similar to, what's the word that we use? Proportional. So be careful with that, because a lot of people, when you guys were doing the 2-column proof yesterday on the quiz, a lot of people were forgetting that word, proportional. That's what you're looking for. You're not looking for sides to be congruent. You're looking for them to be proportional. How come 2 has to be similar? How do you know that? How do you know 2 is similar? So a lot of people put SSS. How do you know that, though?
Because it has the tallies on it.
It has the tallies, but they're not the same. So how do you know that that has to be proportional then?
What do you mean like not the same? Like,
Well, this is not the same tally as the WXY one. So how come everybody put SSS, but why is that? Because they're not congruent to each other. So how do you know that they have to be similar? What do you mean? What? Okay. But what does that help you with in number 2? The sides have to be proportional because no matter what, it doesn't matter what proportion they are. Let's say this is 6. What's this? And what's this? And if this is like anything else, let's say that's 5. So what are these? 5. And 5. So no matter what those sides are, they have to be proportional. Okay, the other way you could do it is these are what kind of triangles? They're what? They're not isosceles, they're equilateral. And if they're equilateral, that means they're also equiangular, which means how much are each of the angles? 60, 60, 60. So you know that these are also 60, 60, 60. So you could technically use either SSS or you could use AA here. Because if they're equilateral, they must be equiangular. So you know 2 of the angles are equal. Okay, so how are we going to use these similar triangles and these properties of similar triangles to help us solve things about actual triangles? So take a look at this triangle ABC. In this picture, ABC, what's going on? There's another line that's intersecting the triangle, and these arrows mean that it's what? Parallel to it. So if you have a parallel line that intersects a triangle, if you know that EF is parallel to BC, then you also know that it divides the sides proportionally. All right, so for instance, in this triangle, EA would be proportional to AB. EA, so this little piece is proportional to AB, and AF is proportional to AC. Sorry, AF and FC. It divides these proportionally. So this and this are in the same proportion as this and this. So for example, if you know that this is proportional to this, and this is 4, and this is 12, then if this is 3, what would this be? 9. Why? Because if you multiply 4 by 3, you get 12, and if you multiply 3 by 3, you get 9. So it splits them proportionally. So if this one is 4 and this one is 3, then if this piece is 12, this piece must be 9. So these pieces, this right here, is proportional to this, and this is proportional to this. Yes?
but it doesn't have to be 1/3, right?
No, it doesn't have to be 1/3. It could be 1/4, 1/5, just whatever it is. So for instance, yeah, that's a good question, because with the medians ones that we talked about before, they were always 1/3. So let's say that this is 5 and this is 20. Then if this were 24, what would this little piece be here? 6. Why? Okay, so 20 to get 5, you divide by 4. If you divide 24 by 4, you get 6. Good. Okay, so it doesn't have to be 1/3. It just has to be proportional.
Wait, what? How does it have to get 6?
Well, if this was 20 and this was 5, what do you do to 20 to get to 5? Okay, so if this is 24, what do you do to get this piece? What's 24 divided by 4? 6. Okay, so if you don't know that off the top of your head, you could always say, Okay, so there's proportional, now I gotta edit this whole video, so annoying. All right, so there's proportional relationships between them as long as these two lines are what? Parallel to each other, okay? If those two lines are parallel. What could you tell me about this angle and this angle? They're corresponding, which means that they are... Oh, good joke. All right, so they're not exterior. This one is exterior, this one is interior, but corresponding means that they must be equal to each other. All right, so they're equal to each other. Okay, so then if you have something like this, where these are also parallel, all right, and this were like 3, and this were 17, and this were 2. I don't know what this is off the top of my head, so what could you do to figure out this one? Make a proportion. What would be your proportion here? Could be 3 over 2, or it could be 3 over 17 equals 2 over x. Okay, and so then you would just solve that proportion. So again, if you looked at this one up here and you were like, well, I don't know what I have to do to get from 20 to 5, then you can set up a proportion there. All right? If you figured out this, what else could you figure out? You could figure out the entire lengths of the triangles. Okay, so it's also proportional to the total side length. Because what would you have to do to get this whole one? Add them together, which would give you 20. All right, so you could do like 3 over 20 equals 2 over x and get this whole side right here as well. Okay, because the little triangle and the big triangle must be similar. All right. If a line divides two sides of a triangle proportionally, then it's parallel to the third side. So this is just the converse, so that means it's backwards. So for instance, if I tell you this, and I tell you this is 5, and this is 10, and this is 4, and this is 8, then what could you tell me about line L and line M? They're parallel, because what can you tell me about these two pieces? Yeah, you multiply by 2, so they are proportional. Therefore, the line L is parallel to line M. Okay? So all that means is the converse just means you're flipping it backwards. So if they're proportional, you can prove that these two are parallel. If they're parallel, you know that they're proportional. So it's just back and forth. So converse and the additional or the original conditional statement. All right, so how would we use that to find CY? So what, 9 over 4 equals 10 over x. All right, and then what would you do to solve that proportion? Which would give you, Bianca? Yeah, go ahead.
How come you can't do, can you do 4 over 9?
Yeah, you could do 4 over 9. You could do 4 over 9 equals x over 10. Because either way, you're still multiplying 4 times 10. And 9 times x. So that doesn't really matter. The proportion doesn't matter as long as you're lining up the right stuff. All right, so there's a lot of different ways you can line it up. Okay, what's 4 times 10?
40.
And 9 times x?
9.
And then how do I finish? How many times does 9 go into 40?
4.4.
4 and 4/9, or 4.4 repeating.
So then that would be the answer?
So that would be CY. Because 40 divided by 9 goes in 4 times, 36, 4 over 9. So that's your remainder. That's your dividend. Or if you do it on a calculator and you get the decimal, it's 4.4 repeating. It's the same thing. I just do fractions because I can do them in my head. All right, so how would I verify in this one that MN is parallel to KL? How would I verify that MN is parallel to KL? You figure out if the sides are proportional. Are these proportional?
Yes.
Yes, because what do you do to go from 21 to 42? And then 15 to 30? Good, multiply by 2.
For those,
Yeah.
do you always have to multiply? Can you just find the proportion?
Yeah, you can set up the proportion to just make sure it works. Yeah. As long as it works, you're fine. Or like you did in the rewind, just divide them and figure out if they give you the same decimal, which would be in this case 2. All right, yes, either one would work.
If you set up the proportion, do they have to equal each other?
If say that again?
If you set up the proportion, do they have to equal?
They would have to equal each other if these two lines were parallel. If they didn't equal each other, you would say MN is not parallel to KL. Okay. All right, go do these 6. Okay, so, good morning. Can somebody come do number 6 on the board, please? Can somebody come do number 6? Bianca?
Did you get tangled?
Okay, so 12 over 16. Where did the 16 come from? You have to add those two together. How come you can't just do 12 over 4?
Because we don't know what x is for.
Yeah, you don't know what that little part is, and you don't know what x is, so you'd end up with too many variables. Okay, good. And then if you solve it, what do you end up getting?
X equals 15.
Good, x equals 15. Perfect. So just make sure if you don't have, or if there's pieces that are unknown, you can't just decide, well, if this is 4, I don't know what this is. Technically, you could do this. You could say 4 over 20 minus x, because that would give you this little piece. But don't make it more complicated if you don't have to, right? Like, that would give you the right thing. It would just be more work, because you'd end up having to factor. Okay. All right, so a 2 transversal proportionality means if you have 3 or more parallel lines that intersect 2 transversals. So we've got 3 parallel lines right here, A, B, C, D, and E, F. And we've got 2 transversals, A, E, and B, F. Then they divide the transversals proportionally. So that means this piece here is proportional to this piece here. And BD is proportional to DF. So again, we've got 3 parallel lines divided by 2 transversals. And a transversal just means what? Cuts through the parallel lines. So if this were 4 and this were 6 and this were 2, how could you figure out this one?
Will be 4? No?
Not 4, but how could you figure it out?
6 divided.
You could do that and find the decimal, or you can set up a, what would be the proportion here? 4 over 6 equals 2 over x. What's 4 times x? And what's 6 times 2? So what's 12 divided by 4? So this must be 3. Okay, so 2 transversals cutting through 3 parallel lines cuts these into proportional pieces. What? Go back? Yeah. So it would be this piece right here, this 4 is proportional to the 6, so the 2 has to be proportional to whatever that is. All right, and the last one is the triangle angle bisector theorem, which says an angle bisector of a triangle divides the opposite sides into 2 segments whose lengths are proportional to the lengths of the 2 sides. So let's go through what that means. That means BD, so this piece right here, is proportional to DC, and AB over AC is proportional in the same way. So again, if this is an angle bisector, which means that these 2 angles are what? Congruent. They don't have to be 90 necessarily, but they have to be congruent. That means if this were 4 and this were 12 and this were 8, what would this be? 24. Why? Good. So 4 to 12, you multiply by 3. So then you multiply 8 by 3 to get 24.
That's it?
Mm-hmm.
So what is this term just saying?
Saying that if these, like if this is an angle bisector, then this bottom line and this bottom line are in the same proportion as the sides. Okay, so could you find x? Yes, how? 13 times 3 gives you 39, so then 6 times 3 gives you 18. So that would have to be 18.
Sides,
Yeah, so the two outside sides are proportional and the two bottom pieces are proportional. All right, so this one to this one, and then this side over here is proportional to this side. So the outside legs and then the two bottom parts.
That's only if the angle.
Only if it's an angle bisector. Okay, so if I want to find RV and VT, how would I do it? Here's my angle bisector. So what proportion could I set up here?
we're going to do x plus 2 over 2x
2x plus 1 equals,
10 over 4.
good, perfect, 10 over 14. So this piece to this piece and this one to this one. How come it's 10 over 14? How come it's 10 over 14 and not 14 over 10?
Because you did x plus 2 first.
Yeah, because the x plus 2 was first, so you have to pick the side that's next to the x plus 2. All right, now how would you do this? Distribute. So you end up with what when you multiply these two? 14x
28
plus 28 equals
20x plus
10. Good. Now what? Am I going to have to factor here? No. How do you know that I don't have to factor? Yeah, you can get rid of the x's. There's no x squared. All right, there's no x squared. So then what are we going to do?
bring 20, negative 20, okay, subtract 20x to, oh, no, 14x.
Why 14x? Good catch. Why that one? Then it keeps it positive. So minus 14x, and then I also have to do minus 10, minus 10. So I end up with, what's 28 minus 10? And what's 20 minus 14? So then x must equal 3. And then how would you find VT and RT? I'm sorry, RV and VT. Good. So if x is 3, then this would be, if x is 3, what's this? 5. And if x is 3, what's this? 7. Okay, go try these 6.